All right, are you all ready to go ahead and get started? Hi, everybody. How are you all doing today? Yeah? Did you all get a chance to watch that special video I put up for you? How was it? Was it okay? I just did it sitting on my sofa one evening, and so was it useful? How could I improve the videos, if you have any suggestions? When I just have to hack one up like that? No, it's perfect. Should be syndicated, probably. All right, so we watched the additional makeup video for today, and what was in there? A couple of things. One was, all right, you're on the spot here. So opening files with a string file name, did you all see that? Did that solve anybody's problems? Some people had run into the problem already where they didn't have the right C. Okay. And the other thing we had in there was switch statement. What does a switch statement do? Yes? Okay, so it allows you to pick an individual item, right? Match something exactly. And what types are we allowed to match using a switch statement? Can we match floats? Can we match strings? How many of you actually watched the video? Okay, what else can we match? Can we match doubles? Yeah. We can match characters and one other thing. Integers, that's it, characters and integers. And here's a secret, we can't really match characters. Why do you think we can match characters? Because there's really a magic code behind the character that is an integer. So switch really allows us to match integers, and it's just a quirk that characters have this code behind them that we can represent them that way. Oh my goodness, it's time for another exciting episode of The Code is Right. What do you think this is going to be based on? The video. Okay, well, I have an exciting new thing that I did for you. I wrote a little program just for us, and it's called Come On Down. And Come On Down has a file of all your names. It keeps track of how many times you've been called up to play The Code is Right. And over the semester, it picks people preferentially who haven't been up here before. If you played this game already, I already gave you credit before. So let's see, we need 3 people to play today. Let's get back to what we were doing. So we've selected our players, and by the way, when I make the class video, I'm going to edit your names out because just for privacy reason. All right, so this time, can you all see the code? You can step over a little if you need to see. Here's our switch statement. What's going to happen after you read this is when we get ready, we're going to have some input. And when I give you input, you're going to have to tell me what the switch statement outputs. Okay? So take a moment, we'll look through this. Int main, char C, C into C, switch on C, case A, C out dog, case N, C out pig, case X, C out bat, default, C out wingo. Okay? You all ready? Are you glad you watched the video now? Did you watch the video? We'll find out. We'll find out. Okay, so player selection is complete. I've showed you this. Are you ready? The input is X. Oh, purple player. Yes, sir. What does this output? It outputs bat. You are correct. All right, we'll reset, and we'll get ready for the next round. The answer was X outputs bat. Why does it output bat? I forgot. I wanted to do this part too. Uh-huh. Yeah. Yeah. So that should be lowercase, by the way. Okay. So there's an X. It matches the case X. It C outs bat. It breaks. We're done. So it should C out bat. Everybody good with that? All right. Are you ready for another input? Yes. Player is ready. The input is A. Oh, green player. It goes to wingo. Oh. Next player. Wait, let me reset and someone else can buzz in. Orange player. What? Oh, come on. That's what I get for rushing. You're right, too. So it does go to wingo. Someone dropped their go card. It does go to wingo because it's capital A, but if it were lowercase a, or alternatively, if I had enough room on the slide to put both cases in, which I did not, don't even ask questions like that. Okay, thou shall not mix characters and ASCII values, ASCII integers. Okay, all right. So you're right. It was wingo, but if it was A, it would have been dog. All right. From here on out, I want you to make a pretend in your mind. Pretend any uppercase letter in the input is actually lowercase. All right. Are we all good with that? You're good with that? Yes, so uppercase is actually lowercase, all right? All right, so the answer was, since it was A, if it was uppercase A, it would hit the default because there was no uppercase A, but if it was lowercase a, it would have hit dog, okay? But from here on out, all input is, come on, one more time, is, all right, good job. All right, get ready, let me reset. I think we're reset. Can you someone hit their buzzer? Anyone? Okay. All right, one more time, we're gonna have one more input. If it shows up as uppercase, it's actually, all right, are you ready? Players, go! Oh, green player, what's the answer? Oh, all right. So his answer was, it's whatever n's input is, fig, plus whatever x is, because there was no break in between. Okay? When you have a case that there's one thing and then another with no break in between, it will fall through to the next case. Now, let me tell you something. If you see this in the real world, 99% of the time it's wrong. It's a bug. Almost always when there's no break, there's a bug. And it's very common, if you actually want for things to fall through, to put a comment there saying this is not a bug. All right, there are very few cases where you actually want it to fall through, but since it's an N, it hits the pig case, and then it automatically keeps going, does the back case until it hits the break. So, all right, thanks to our contestants. All right, thank you very much, gentlemen. Just put it right back down there. We'll probably be using those again today. So. All right, any questions about switch statements? When you had a switch statement, you can put anything inside the switch statement you want. So when you have a particular case, you can have anything inside that you want. When I wrote my master's thesis, which was a very, very long time ago at this point, my entire thesis was essentially a switch statement inside a switch statement inside a switch statement. It was a network protocol. It read part of the protocol, and it would go to the switch, read part of the message, go to the switch. It was just a giant nested switch statement. It was huge. So switch statements are awesome. Any questions about switch? Everybody understands the falling through thing? So when I actually put something on the exam that falls through on purpose, you're not going to miss it? Yes? No, I say no. Okay. Last time, so that was the video. Last time we talked about a few things in class. We talked about while loops. When do we use a while loop? Yes? Okay, so it's something that keeps going, and a better way to phrase it? Yeah. An indefinite number of times, right? It's going to happen, it's just going to happen in indefinite times. It's used for, like, when somebody types a file name on the keyboard and they screw it up and you want to give them another chance. How many times is it going to take that dumb human to get it right? Yeah, we don't know, potentially a lot, right? If you have like a game, if you're playing a game and you want your game to continue while people are making moves, how many moves does the player get to take in that game? In general, we don't know, right? If it's tic-tac-toe, we can say it's going to be less than 9, right? But in most games, we don't know how many moves. So while loops just go an indefinite period of time. We use them for things like reading information from files. For loops, who wants to tell me what a for loop is for? Yes? Yep, when you have a definite idea of how many times it's going to be run, right? Like you don't have to know yourself, like the count of how many times, but you have to be able to specify exactly how many times it's going to be run and what you want to happen each time the loop iterates. The do loop, yes sir? Yes, it's like a while loop. It will do things an indefinite number of times, but it will always do it at least one time, okay? Regardless of what the condition is, because it will do the body of the loop first. All right, questions on loops so far? No? All right. Oh, my goodness, it's time for another exciting round of The Code is Right. What do you think this one's going to be about? Loops. All right, so let's do some player selection. We have some loops, and I know we've been working on loops for a while, so these questions are a little bit more challenging. A little bit more challenging, okay? And the other thing is when you're done, I'm going to hide the code. You have to explain your answer without looking at the code. So don't click in until you're ready to tell me the answer, all right? Are you all ready? Yes? All right, so I'm just going to flash a piece of code up, and you have to tell me what the output is. Are you ready? Oh, orange player, yes, sir. Oh, wait, I accidentally put that one up early. Okay, it's the same thing, though. 10-7-4-1. How many of y'all think that's right? 10-7-4-1 is right. Yay! Now explain why. Uh-huh. Yep. Yep. So the first it starts at 10, outputs 10, subtracts 3 from 10, and you get? So is 7 greater than 0? So it's the next one is 7. 7 minus 3 is? So it outputs 4. Is 4 greater than 0? Subtract 3 from 4, you get? Output 1. Is 1 greater than 0? Subtract 3 from 1, you get? Negative 2. Is negative 2 greater than 0? It is not, so it stops. So the output is 10-7-4-1. Sir? Uh-huh. It would print out negative 2. Well, you'd have an error. You can't have an I after the for loop, but we'll learn about that later. Trust me on this. Okay? But that is correct. And so you sir, what do you got? Snickers? Twix? All right. So that was correct. Next loop. Are you all ready? I think you got some tough competition today. Yeah, absolutely. Sort of. Maybe. You have to be able to guess what the ASCII values are. How's that? Oh, yes, sir. Green player. No. All right. Someone else want to buzz in? Yes, orange player. No. You're close. Where are we starting from? And then what does it do? Yes, you're right, actually. You're absolutely right. It's C, E, and G. Yay! That was a very tricky one here. You too. All right, so you might ask yourself, what the hell is going on with this, right? Because I've thrown something weird in at you, and I just did it because if I did it with numbers, this would be too easy. But remember, what is a character behind it? An ASCII value. And it turns out, and if you didn't know this, then I'm a jerk for throwing this on the question, and you all handled very well. You can add to ASCII values, and what it does is it moves up to the next ASCII value. So if you add 1 to A, you get B, but I threw in a 2, so you would have to go BC, right? And I put it so that it was adding before the output, so you're correct. It did CEG, which was awesome. All right? Because what happens is it adds first and then outputs and then finds out that it's bigger, right? Pardon? You can, yeah, it wouldn't in a for loop. So, all right, did everybody kind of get this? Yes? Because it adds before it first. It says, okay, we're A. Is A less than G? Yes, it is. So now we add 2 to what C is, and so it goes from A to B to C. Output C goes back up. Is C less than G? It is. So it adds 2. It goes DE because it adds 2 to it. Outputs E. Is E less than G? So it adds 2, FG, it outputs G. Now it goes back, and is G less than G? No, it's not. So. This is different. Each loop is a little bit different. So. All right. That was a tough one. Are you ready for one more? You all did. Actually, you all handled that pretty well, I have to say, considering that I threw in some stuff you'd never seen before. Okay. One more loop. What do you think this is going to be? Are you expecting a do loop? All right. Are you ready? Yes. What does it say? What does it output? What does it output? What does it start? What is the first output? Actually, you're correct. It starts at 0. I have the wrong answer typed there. Yay! So here's what happens, and I'm sorry I just typed that out. I meant to cut and paste. So it starts at 0. The first thing it outputs is, and then it adds 1 to it. So it'll be 1. And then is 1 greater than 0? It does. And so from here on out, each time it prints out the number, adds 1 to it. So you get an infinite sequence, and I missed the 0 on there, which you got correct. So bonus for you. Did you get anything? Oh, consolation prize. All right, thank you very much. Round of applause for our contestants. Yes, sir. Uh-huh. It would. Yeah, it wouldn't print out 0. It would print out. It would start at 1 instead of 0. So, and my output here is an error, and I'm just going to go ahead and fix it. So the next time I cut and paste the slides for my next class, which I will probably do again someday, I won't be completely wrong. So I think that's correct now. All right, everybody happy with this? Yes, sir. Okay. All right. So these are the kind of loops that you can expect to see on the exam. I will give you little questions like this, and you will have to be able to figure out what the output is. Sometimes you'll have to be able to figure it out, and it'll be doing more than just printing things out in here. I might give you a loop, for example, that has a switch statement inside. So you have to know what the loop does and then figure out what the switch does with each particular number. Does that make sense? Yes? They'll be on the video. So, I mean, I have code. If you email me, I'll try and remember. But I did them someplace else at home, and I don't have them on this computer. So, anyway, these are pretty small. You can type these pretty easily. All right. Any other questions? Thanks again to our contestants. All right. So now let's start talking about a little bit of new material. I don't know if you encountered this. How many of y'all read about loops in the book? A few of you. How many are actually reading the book? How many of y'all think the book is good? Useful? How many are not enamored with the book? It's okay if you don't like it. I'm curious. It's the first time I'm using it, so. All right, so let's talk a little bit about modifiers in loops. So here's the deal. We have, if I can get my code here. All right. Oh man, hang on. Sorry about this. It's this weird thing where I get into full screen mode and it's hard to get out. So, hello. Okay. I went right back into full screen again. Yeah, there's some, because it's Emacs, there is some sort of key that does it, but it's like Command Alt Meta Shift X, and I haven't looked it up and memorized it yet. So. Okay, so what I'm going to do is I'm going to make a little program here, pound include, I'll make the font bigger in a second, stream. All right, here's our standard little program. What does this program do? Nothing. It's a base program. It starts and stops. All right, so there are times, and I don't have a really good example for you of this, but there are times when you're going through a loop that the loop will step through every single thing one after another. But there are particular times where when you're in the loop, you don't necessarily want to work with a particular item. Okay, let me think of a good example of this. Okay, let's say that we are looking at numbers, and we want to loop through a whole bunch of numbers and determine if a particular number is prime or not. Okay, do you all remember what prime numbers are? They are numbers that are divisible by themselves and 1. Okay, What is a really quick way of telling if a number is prime or not? Pardon? If I give you a particular number, is there something you can use about that number to tell if it's prime very quickly or not? Divisible by 2. Numbers that are divisible by 2 are not prime, right? They are not prime. Pardon? Other than 2, yes, sorry. Numbers that are divisible by 2 are not prime. Now, is finding prime numbers an important operation? How many of y'all think it is? What's it used for? Cryptography. So all the security on websites, encryption for your email, all sorts of stuff involves encryption, and there's a particular type of encryption that's based entirely on prime numbers. And so the code that does this has to be able to generate prime numbers very easily, and so what essentially it does is it creates a number and then tries to figure out if it's prime. It just generates it randomly and it runs some tests on it to figure out if it's prime. Okay? So let's say we want to make a loop, and our loop is going to be pretty easy because, you know, we're not dealing with 800 or 1,000 digit numbers. We're just going to loop over a bunch of things from, say, 1 to 100. And we want to be able to tell which of these things, 100 is too big, let's do 10. Which of these things, gosh, this is not a good example, but I'm going to continue on it because I put so much time into it already. We're going to try and tell which of these numbers that we generate is worth checking out to see if it's prime or not. Does that make sense? So one of the things we can do is when we get a number, we can say if our number, and how do we check if it's divisible by 2 or not? Yeah, and then what? Equals 0. So what we can say is if our number, mod 2, is equal to 0, we know it's even, and if it's even, it can't be what? So what we'd like to do in this case is we'd like to move on and do some other stuff, right? So down here we would do some other tests. Down here we would do some other tests for primality. Like sieve or arithmeses and things like that. Okay? But if it can't be prime, we don't want to look at it. So what do? Well, now all we know is if we have an if statement, we could have an else down below, right? Couldn't we? We could say if it's not prime, else. Well, there's another way of doing the same thing. And the thing that you can do is you can put something in here called continue. And notice continue turned purple. My editor Emacs knows the words that are special to C++ and turns them purple, so continue turned purple because it is a special word in C++. Anybody want to guess what continue does? Yes, it does continue. What does it mean to continue in this case? Nope. Yeah, so what continue says, continue means, in this case, continue means go to the next loop iteration. So continue means this particular iteration of the loop isn't working out for me. We're done with it. Let's just go on to the next one. Does that make sense? Thumbs up? Yep. All right. So let's just test this out for a minute. We'll compile it. What did I call that? All right, so compiled cleanly, we're happy. And when I run it, would help if I had a cout statement or something, right? Wouldn't it? Yeah, it got pushed down below the bottom of the screen. Sorry. My font's a little bit too big here. I can't get most of the code on the screen at once. Okay. So here's what we're doing. What we're going to see is we're going to see if something is mod 2, 0, it can't be prime. We're going to go on to the next thing. Otherwise, output I. And these would be the numbers that we're actually checking to see if they're prime. What numbers do we expect to see here? Will we see 0 here? I actually don't know. I probably should know that, but I'll find out really soon. So we see 1, 3, 5, 7, and 9. Okay. 1, 3, 5, 7, and 9. So we can see that what happens is every time we have an even number here, it continues, and continue means go up to the loop and do the next iteration, and it never reaches this cout statement. Does that make sense? Sir?
Not exactly.
Okay. Sure. In what way does it not make sense to you?
If the continue statement wasn't there,
Mm-hmm.
what would happen?
Do you want to see what the continue statement is? Let's just take it out and I'll show you what happened. What's going to happen is it's going to print every single number in the loop. Okay, so we take the continue statement out. So we have this if I mod 2 equals 0, it can't be prime. We take the continue out, otherwise we have that cout I. If we compile this and we run it now, I'll clear the screen first, and we run it now, every number is there. Every single number is there. And the reason is that we're checking to see if it's even by modding 2, but then we're not doing anything about it. We're not doing anything about it. If we put this continue back in, it means when you reach here, find a loop, find the most recent loop you saw, which is in this case the for loop, and go on to the next iteration of that. So it stops processing right here. It says, okay, I got a even number. I'm stopping and I'm going right back up here to the for loop instead of going down below. Yeah, once it hits this continue statement, it goes back up to the loop. For a for loop, it will increment, absolutely. Mm-hmm. Yep, absolutely. Yes, sir. How's that? I mean, we know that 2 is prime, so we might as well just start a loop from 3. Okay, that's why I'm saying it's a bad example, because I could just do plus equal 2 here and only check the prime numbers. I was so excited making up this game stuff, I forgot to come up with a good example of this before class. So I hope you enjoyed the game as much as you are not enjoying this right now. But we'll just pretend it's like that. So do you see what's happening here? Yes, sir. Yeah, we could put a cout statement here and say cout. We were ignoring. I mean, it's the same thing, right? So, I mod 2 equals 0. It can't be prime, so we're ignoring it. Otherwise, we continue, and we go on to the next number. So if you see this now, we're still going to print out the same. It's going to print out 0, ignoring. It's going to print out ignoring 0, 2, 4, 6, 8. So it shows you that it's skipping and going on. All right, everybody kind of understand that a little bit? Continue means we are done with this iteration of the loop, and we're going to go on. Yes, sir? So I'm not removing anything. What's happening, so I don't want to remove anything. Don't think about it in removing. Think about it in terms of which steps the program executes, okay? So where do we start tracing code from when we have code? Let's just step through this and I'll show you how it works. Where do we start tracing code from? We start at int main. The first thing that happens is we say for int I equals 0, I less than 10, I plus plus. So we have I equals 0. Is 0 less than 10? Absolutely. So it goes to the next line of code. I mod 2 equals 0. Is 0 mod 2 equals 0? It does. So it comes in here and it says, oh, continue. When it sees that continue statement, what it does then is it says, okay, I am done with the body of the loop. I have to do my I plus plus, so now I becomes, and it goes right back up here to the for loop again. So it's not skipping anything, it's just not going to the rest of the body of the loop at that point. It just stops at that point, and it goes back to the next iteration. Does that make sense? Who's with me? Who's against me? Okay. All right. Everybody think they're good with continue? I want to do it in another loop too. Let's do another kind of loop. What other kind of loop can we use continue for? Let's do a while. All right. So what we're going to do is we're going to change this to a while loop. All right, so here's what I'm going to say. We say, And let's leave this other output in here. All right, so I changed our for loop to an I loop. So let's just step through and look at this code. We start by setting I equal to 0. We say while I is less than 10. Is 0 less than 10? Yes, it is, for very large values of 10, at least. So it's going to go in loops. Is I mod 2 equal to 0? Is it true for 0? So it should output ignoring 0. It continues and it goes back up. Okay? What? That won't increment. I don't know what you're talking about. Let's just try it and see what happens. All right. Whoa. It's not entirely what I expected. Oh, it would be helpful if I actually output I in there too, wouldn't it? Somebody trying to tell me that before? Okay. All right. So when we run this now, it just says ignoring I over and over and over and over. And you can't actually see it, but it is actually, if I push the space button, you can see it flickering. It's just printing it so fast that it appears as a solid thing. All right. Why is it doing the same thing over and over and over again? Yes, sir. I did increment. The increment's right here. Exactly. So in the for loop, part of going on to the next iteration is automatically doing that increment, which in our case was plus plus, right? But in this case, with a while loop, what happens is we start up here, we say int I equals 0, 0 is less than 10, 0 mod 2 is 0, that's true, so we print out ignoring 0 and we continue. And we go up to here and we do the test again. But because it's a while loop, we didn't actually reach the incrementer and it will just run on wildly forever. Everybody with me on that? Everybody understand what continue does? Continue says, oh, I'm in the middle of the loop, I found something I'm not interested in, I'm going to go on to the next iteration of the loop. Often you'll do this in a file, like let's say I gave you a file that had a bunch of names and genders, right? And you're only interested in one gender and not the other. You could read the line and see if it was a gender you were interested in, and if not, skip and go on to the next line. Does that make sense? Which gives me an idea for the next project, actually. All right, questions on continue? Going once? Twice? All right. So sometimes the other thing that will happen is that you'll be in the middle of a loop and you'll be running along and you'll realize that in fact you are done with the loop. It's not, you might be reading let me give you an example. Let's say you're reading a file and you're looking for a particular name in the file. All right. So let's say that we're the NSA and we have a collection of billions and billions of records about phone numbers and you're trying to find out if a particular phone number is in your records. You with me? You start reading the file and you read the file one line at a time. And each time you read the line, you look at the phone number. And if the phone number that you find is in there, then what's the answer to our question? Yes, we found that particular phone number. It's in there. Do we need to read the other 20 billion lines of data at that point? We don't. So at that point, we're happy to just stop reading. So just like we have continue, we can also have something else, and it is called, in this case, is just an example, I mod 5 for no particular reason. Well, let's start this at 1 then if we're going to do that. I mod 5. So anytime we see 2, we want to skip it, and anytime we want to see 5, something's divisible by 5, we quit. All right. Trying to do some better screen management here, but my font's pretty big. All right. So here we are. I don't even know why they have cap lock anymore. Jeez. All right, so like we have continue will go to the next iteration of the loop. For loop, it'll do the iterator first. We also have this word break. And what break does is break exits the loop. It goes on to the next thing. So if we put something down here saying done with loop, we should see that. So here's the same code, right? We have our while loop starting at 1 while it's less than 10. If it's mod 2, we say we're ignoring it. If it's mod 5, we print out it's divisible by 5 and we're ending the loop, and then we break. And what break should do is, at this point, it doesn't go back up to the top. It finds the bottom of the loop, which is right down here, and then starts executing code after that. All right, everybody with me on this? Questions so far? Yes? Well, this is a super contrived example, and we would have to change our algorithm a little bit. The algorithm I'm implementing here is that if the number is divisible by 2, we go on to the next number without incrementing, which is going to be a problem. So I'll have to add our incrementer here. But we'll also have to add it elsewhere. God, I shouldn't have done this in a while loop. I spent too much time on the code is right today and not enough time on my other examples. So here, you know what I'm going to do? I'm going to cheat. I'm going to pull this code out. I'm going to go back to the for loop. I don't want to go into that. I really don't, because I'd have to think about it, and I don't want to think right now. So it's obviously not working very well for me. Okay, so let's put this in the for loop, and now we don't have to worry about where the incrementer happens, okay? And we'll go back and add this line down here. Sorry about this. All the code will be online eventually. All right, so now it's the same thing. We're just using a for loop. If it's mod 2, continue. If it's mod 5, we break, and we'll show you what break does, which is it ends the loop. So let's go ahead and see if this works again. All right, that compiled. We'll run it. Ignoring 0, prints out 1. Ignoring 2, prints out 3. Ignoring 4, 5. 5 is divisible by 5. Ending loop. We're done with loop. So break stops the loop. Next time I teach this, I'm actually going to have an example of the NSA thing with phone numbers and stuff, because then we can look for particular area codes and we can stop for looking for a particular one. So note to self, if you remember to watch this video next year before you teach this class, use the NSA example. Okay, good. Any questions? No? Have I completely lost you? I have, haven't I? You've got that numbed silence. That means that I screwed up teaching today. Come on, the code is right part was fun, wasn't it? All right. How many of you all are lost on this now? Oh, damn it, I knew it. Okay. How many of you are not lost? How many of you are in some sort of determinate not lost and not lost state in between? All right. So here's the rule, okay? If you put break inside a loop, the loop's just going to end. It's just going to end, no matter what. Maybe I should have looked at my notes too. This is actually what I have in my notes. So. All right. All right, let's take a 1-minute break. I'll try and think about what I'm going to do. Recover, stand up, stretch, jump up and down, shriek. Send emails to the dean and tell them I'm doing a bad job today. Okay. All right, welcome back. I took a 2-minute break so that I could actually create the example I should have created at first. Hopefully this will just compile beautifully and it'll be a testimony to my amazing skill at writing very simple C++ programs. So here's what I've done. I haven't tried to compile it yet, which is bad because I should compile as I go along to catch small mistakes, but I was in a rush, and so I'm just crossing my fingers and hoping for the best here. So here's what we're doing. I'm going to show you what continue and break do in the context of processing a large set of phone numbers. So what we have over here is our file. It's called phone.txt. It has an area code and a phone number separated by a space. Okay? Now, I only put 6 in there because I didn't have time to type like 100 or 200 million of them, right, in a minute or two. Pardon? I could have also made a program to generate those, but I couldn't do that in like 2 minutes while you were standing right there. So we have 6 phone numbers. Do you want me to add some more? Anybody want to tell me your phone number? I'll put it in here. It'll be on the internet. So, all right. So we have some phone numbers. And here's what our algorithm is. We're given a giant list of phone numbers, and we're interested in phone numbers that are only from the 703 area code. Okay? 703 area code. Anybody know where 703 is? Northern Virginia? Okay. Anybody listen to the Postal Service? They mentioned this area code in their song. You want to sing it for us? Okay. Actually, I'm not thinking, is it Death Cab? No, it's Death Cab that has a song about singing something. Anyway, see, I'm cool. I'm hip. I know what you kids like. All right. So here's what we're going to do. We're going to do the standard stuff that reads the things from a file. We have an input file. It's named phone.txt. We'll check that it's open. And once we do that, we'll start reading the area code and number. And what it's going to do, it's going to print out which area code and number it's processing at the time. All right? Now what we're going to do is we're going to check and we're going to say if the area code is not 703, if it's not, then we know it's not going to be the right number, is it? Because we're looking for only a particular number in the 703 area code. So once we see that the area code is not 703, we don't have to look at the rest of the number. Does that make sense? So we'll finish just a little bit faster because instead of having to check hundreds of millions of numbers individually, we just check the area code, and if it's not what we want, then we just go on to the next thing. Okay? Everybody with me on that? So that's why we say wrong area code skipping and continue. Otherwise, if we don't continue, we actually have to check the actual number. And the number we're looking for is 5450012, which I sincerely hope is not a real number. And if we find it, we're going to output number found, and then we're going to break. And we're going to break because we don't have to keep looking at numbers. We've found the ones we wanted. Everybody with me on this? So you just see, why are we using continue here? Because we don't have to keep looking. We already started looking and we know it's wrong, so there's no point in doing more work, right? Does that make sense? And if we find the particular number we found, we know it's in there, there's no point in reading the rest of the file. We can just stop. All right, so let's see if I can do immaculate typing. IFstream input file. What did I mess up there? Template. Oh, I didn't declare input file. Did I? Oh, I forgot to put fstream up here. Oh, dang. I did. I just forgot to put pound include fstream, so it didn't know what an fstream was. Now it might work. That's pretty good, isn't it? All right, so let's run this and see what happens. So it processes 703, and it sees it at 703, so it doesn't continue, but the number isn't right. It processes 202, and it goes, oh, that's the wrong area code. I'm skipping. Right? Processes this, wrong area code skipping, processes 703, and you can see it doesn't skip because it has to check the number. Why didn't the number work? All right, well, there's 2 errors in my code. And that, honestly, that's like a 30-line code program. That's about how many bugs per lines of code you'll see in normal things. Normally there's like 1 bug every 10 to 15 lines of code and things. So we'll clear this. We'll pretend those didn't happen. And now we'll see it processes the ones that have 703, skips the ones that have 202 and 505, and then when it finds the number, it doesn't keep reading. Okay? Is that a better example? Are you happy now? Everybody, who's with me now? How do you think that was a way better example? How many wish I'd never done the first one in the first place? That would be me. Okay. Other questions about this? No? Y'all happy? Yes, sir. Mm-hmm. I have a long story about that I could tell you sometime. And the answer is, it may or may not be depending on how you're interpreting it. All right, so you want me to tell you my story really fast? One day I was breaking into computers, and I broke into a computer into an account that wasn't the administrator account, but for some weird reason had the power to create administrator accounts. And in the interface where I was breaking in, it asked me for what ID number I wanted. If the ID is 0, then you get to be the admin. So I put in 0, and the tool went, oh, 0 is an admin number. I can't create that. So I put in 00, and it went, oh, 00 is not 0. So it then put it in the admin file, and then I had a root account on that machine. So 00 is not 0 if it's a string. 00 is a 0 if it's an int. Does that make sense? And so this thing I did was converting between strings and ints incorrectly. So, all right. And the statute of limitations is expired. So, all right. So, all right, that was a quick aside. Everybody happy with float and with break and continue now? Yes? All right, good. Oh, look, it's time for another exciting round of The Code is Right. What do you think the topic's going to be? What? Break and continue. Let's select some players. Okay, so here's the idea. What's going to happen is I'm going to put some code up on the board. You're going to look at it, and you have to tell me what the output is, okay? Do you have an inkling what it might be? What code you might have showing up on the screen? Any guesses? Probably what we just did. Yes, that's good. All right. Are you ready? Set, go. Yes, purple player. Yes, correct. That was just a trick one. He warned you up. Oh, sorry, I had 10 on there. It's 5 on here, but you had the same idea. It was just numbers because the loop went straight through without doing anything else. That's all it did. And you were expecting it to be hard after the last round, weren't you? All right. So this one is relatively stored. Start at 0, less than 5. Go up 1 each time. 0, 1, 2, 3, 4, and we're done. All right. You ready for the next one? Yes? It would be the same. It would be the same in this case. Yeah, if you had a while loop. Yeah. For a for loop, when you have this, for a for loop, if you have I++ or plus I, it doesn't matter. The only time it matters is when you're like using that variable I at the same time you're incrementing it and decrementing it, which in general you should not do. It's a shorthand notation, but it makes your code harder to read. I just throw it in there because I'm old and I learned to do it that way and I shouldn't. So, and sometimes I want to test I want to make you confused because it brings me joy. So, not actually, it doesn't. Okay, sorry, y'all ready? All right, so more code this time. You have to tell us what it's going to output. Are you ready? Yes. 0, 1, 2. Why is that? Oops. Exactly. So we start at 0, less than 5. This is almost the same loop we had before. And we say I mod 3 equals 0. When it's divisible 3, we break. And we break, we jump out of the loop. And when we jump out of the loop, we're done. So, you ready? Want another one? All right. One last round. Are you ready? So we've seen a normal loop. We've seen break. What do you think is going to show up this time? Yeah? Okay, here we go. Yes, purple player. Oh, you didn't want to push that? Sorry, that's left over? Okay. Yes. Zero, 1, 2, 4, 6, 8. Okay, so what do you think the output's going to be? Oh, it doesn't do 1, but it does 2 and 4. You're pretty close. So here's the trick here. Before we were looking at I mod 2 equals 0 in the example. I mod 2 was 1 there. So this time it's going to continue every time there's an odd number, right? So it doesn't print out 1, it prints out 2 and 4. So, all right, a round of applause for our contestants. Whoops, sorry. It's like a consolation. You're welcome. You're welcome. All right, thank you for coming up. So, I get it. Yeah, this one? It's the same one. Oh, the one with the continue? The break? Yep. All right. So this is the kind of stuff you can say. Thank you to our contestants again. Show of applause. All right. All right. Any questions? Break and continue. Going once, going twice. All right. Let's do a new topic then. Do you want to stand up and place break for a sec? No? You're pretty quiet. All right, I'm just going to keep talking then, because I like talking. It's fun. They pay me to do it. So, our next project that we're working on after this one for Project 3 is still going to be our refugee camp theme. However, it's going to be slightly different. Instead of calculating water needs, what we're going to be doing is we're going to be taking lists of people's names who happen to be at that refugee camp. And we want, what we're going to do is write a program that will match names. So we'll get a list from each camp of all the people who are there, their age and perhaps their gender. I haven't written that part yet. And then what we want to do is be able to find people at particular camps. Okay? The reason being that sometimes when there's a horrible event and people are forced to be refugees, they get separated from their friends, they get separated from their family, they end up at different camps, and we want some way to be able to tell people where their friends and relatives are. You with me on that? So that's our theme of our project. We're going to be taking a list of people where at camp they're at. So how many people are at a refugee camp? Hopefully less than 100,000 in our current example, potentially a lot. So let's write a new program. We're going to call this names.cc. And what does this program do? So here's our program. So what we want to do is we want a way of being able to keep track of everybody's name who's at the camp, right? So what variable, what type is name? That person's name is a integer? No. That shall not mix those things generally. Okay, so we need the string library because we're going to be keeping track of people's names. All right. So when we have a name, how do we keep track of somebody's name? We say string what? Name. All right, so there's a name. But wait, how many people are we going to have at this camp? We don't know. Is it going to be 0 people? Is it going to be more than 100,000? Hopefully not. So we have this problem now where we have to be able to keep track of a whole lot of different names. So how about this? What? What do you mean that's a lot? I'm only at 3. I got to get up to like 100,000. So just give me a few more minutes, okay? You all tired of me doing this yet? All right. Do you see the problem we have here? We have this problem where in the past we've always been dealing with everything on individual basis, right? We only ever have one of something, right? We have one thing we're reading out of a file. We have one thing we're working with. But now we have this problem where we're going to be working with a lot of the same things, quite a lot of the same things. And here I made it through 5 different names, but this obviously isn't going to work very well, is it? Like obviously we're not going to be able to do like 100,000 or 1 million or 10 million or 1 billion or how many things we have of just naming variables one after another. This is going to suck, right? How many of y'all think this is going to suck? How many of y'all think that because computer geeks are lazy and don't want to have to do things like that, there's a better solution? So here's our better solution. Let me describe to you how it works. We are individually now, in terms of variables, used to carrying all our variables around one at a time. Each variable has its own name, right? In the real world, we sometimes do this. If you go to the store and you buy, what's something you buy at the store? What? You go to the store and you buy candy. What kind of candy are you buying? You go to the store and you buy a Twix, you just have one Twix, right? How about you buy 2 Twix? What happens? You have 2 and you have to carry one. How about if you buy 8 Twix? What happens? You have a whole bunch. How about if you buy 40 Twix? What happens? You buy it in a box, or you put it in a bag. You put it in some sort of container that lets you carry a whole bunch around at the same time. Okay? Does that make sense? How many of y'all ever buy beverages of some kind? Soda? When you go to the store, what kind of soda or other beverage do you buy? Although you're all freshmen, so don't tell me anything illegal. What do you normally buy? Like Diet Coke or something? Coke Zero? Anybody? Vanilla Coke Zero? That's my favorite. It's disgusting. I love it. I don't even know why. I just drink it. I go, this is horrible, but it's really enjoyable. Okay, so you go and you buy a bunch of these things, and you don't just buy like one can at a time. You get a can out of a vending machine, but when you go to the store, they come in a big pack, right, like a box. So what I'm going to teach you now is the first way of viewing one of these things that's called a collection. In computer science, we call them collection. You have a whole bunch, you put them in one place, and it is a collection, and you're able to work with them individually. All right? The idea of this is that we're able to have a whole bunch in the same container. Now, I'm going to comment this part out for a second. I'm not going to take it away because I want to refer to it later. So I'll just comment all that out. Now, what we're going to use for our first container that can hold many things is called a vector. And just like many other things in C++, if we want to use them, we have to do pound include it. Pound include a vector. Once we have that, we can declare a new variable. Anybody want to guess what type it's going to be? A vector. But once we have the vector, we have to tell the vector what it's a collection of. Okay? A vector can only ever hold one type. So here we're going to have a vector of strings. The idea of a vector is that you have a container and you can put things into it and you can get things out of it later on. All right. And then just like we give our variables a name, we're going to say this is a vector of string called names. So vector means it's a collection. This angle bracket string tells us what it's a collection of. Everything in this collection has to be the same type. It has to be homogeneous. That's just the way vectors work. And then the variable is names. Everybody with me so far? So let's add some stuff to our vector. So the easiest way to add is using this method called pushback. And what pushback does is it says, oh, I will take this thing that you're giving me and put it on the end. So the first name is going to be John Doe, and we'll put that into the vector. All right? Everybody with me so far? And then we can add other names as well. John Doe, Jane Doe. I'm not very creative today. John Elk, Jane Elk. And now what's happened when we're done with this is that we have this vector. It's called names, and it has 4 items inside of it. 4 items inside of it. You look concerned. It adds to the back, hence push back. So it looks kind of like this if I was to draw a picture. Initially, what's in the vector? We create it, and what's in there? We know it can hold strings, but are there any strings in there when we create it? There are not. So when we create it, we have a vector, and it looks just like that. It's empty. Okay? The first thing that comes along is we say, oh, let's add John Doe to that, and so it makes space and it puts in there John Doe. Everybody with me? What happens next then? It makes space and it puts in Jane Doe. With me so far? What happens next? Oops, I can spell it. John Elk. And Jane Elk. So all those things are stuffed inside our vector. And now, instead of carrying them around all one at a time, we only have to ever worry about one thing. By analogy, last time in my example here, I was trying to have 5 different strings with names, right? I had 5 different ones. Now I only have one thing. It's called names, and inside it there are 4 different names. With me so far? It's like you've taken your bag and you put some stuff in there. All right, are we done? Why not? Do you really want to put 10,000 more in there? I'll tell you, we can put as many things into this vector as you like. There's no limit to the size of the vector other than the memory in the computer. And the memory in the computer is very big. So you would have a hard time running out, particularly in projects for this class. So, okay. All right. Now, let me ask you a question. Let me ask you, before we could work with each of these names individually so we could look at them, how do we look at one particular individual name in this? And the answer is, yeah. Yes. So what we can do is, once we have this names thing, we can output any particular version, any particular thing by using this square bracket and putting the number of the name we want inside there. Okay? So names is this variable, and this names is the name of the variable, and the square bracket with a number inside indicates which one we want. Now, why did I put a 0 in there? Because in computer science, when we start counting things, we count at 0. Okay? We always start counting at 0. So, what do you think names 0 is going to print out? It should print out the first one that was put in there, which is John Doe. Should we test this and make sure it's working, since we haven't compiled recently? Oops. Okay. All right, so it compiled well, and if we run it, what is it going to print out? What happened? Oh, I forgot to save the most recent edits that I made to it. That would be a problem. Okay, so it prints out. So the idea of a vector is you can put a lot of different stuff in there. For each thing that's in there, you can access it by using the square brackets and telling what slot in the vector you're interested in. Okay, does that make sense? Yes? Nope. So we're just working with vectors now. What we're going to end up doing is we're going to loop over a file, and we're going to read things from the file and stick them in the vector. So essentially what we'll eventually be doing is taking all the stuff out of the file and putting it into a variable in the program so that we can just work with things right there as variables. Does that make sense? I'm just trying to show you kind of how this stuff works. So how about we do this? Cout, angle, name, square bracket, 3. What's this one going to print out? Jane Elk. Why? It's the 4th one. Okay. Oops, sorry. John Doe and Jane Elk, yes. All right. Everybody see how this works? Now the other thing we can do is we can use one of these methods that has a little dot, and you can say @ and give it a number as well. This is equivalent of using the square brackets. So @2 is going to give us what? John Elk. Let's see if that works. Yep, that works. All right, everybody with me? This is called a container, and we can loop over it. Let's say, instead of printing them out individually, we wanted to print out everything that was in there. How would we do that? Yes, sir. A for loop. Why would we use a for loop? But why not a while loop or a do loop? What do we use a for loop for? Yes? Because we know how many times we're going to do it. How many times are we going to do it? How many times? For loop. Okay. So the question is, if I give you a random vector that has some stuff in it, how many things are in it? We don't know. But is there a way we can find out? Yes, there is. So we can say something like for int I equals 0, I less than names dot size. So this dot size method right here will tell you how many things happen to be in that vector. And then we can do something like cout angle name square bracket I angle ENDL. This loop right here, this loop, this is essentially what they invented for loops for. Seriously. I tell you that we use the for loop when you know what we're going to do. We're going to use so many for loops over vectors that you're going to be able to do it in your sleep. I'm sorry if you end up doing it in your sleep, though. So I would wish other things on you. So here's what's going to happen. We're going to print out the names 0, 3, and 2, and then this loop will print out all 4 names, assuming that it works correctly. So here are the first 3 that we printed out, and then here are the 4 that are printed out over the loop. All right? Who's with me? How do you all think this seems pretty convenient? This is pretty convenient. It's awesome. So project 3, what we're going to end up doing is we're going to have a bunch of different vectors to keep track of information about people. And I know project 2's, wait, is today Tuesday or Thursday? Oh, sweet. Okay, so project 2 is due next Tuesday, and then by then project 3 will be posted, and you're already getting a preview of what it'll be like. Any questions before we part for the weekend? Sir? Oh yeah, sure, no problem. And I'm sorry, after class the other day I got distracted and I forgot to put things up, but it was just us doing exercises anyway. I'll put all the code up and put the video up. So, next class. All right, vectors are awesome. They're useful. Sir? No. I don't remember. I think project 3 is due after the midterm. But and then the midterm is Thursday before spring break. It's going to be so hard. But seriously, I make the midterm harder than the final. I try to. Sometimes I succeed too well. So, all right. Why do I make the midterm harder than the final? Because that way I find out, who hasn't really